So hey everyone, we are going to study stack and queue together because the functions and the code base is almost the same. So, okay, now first let's quickly understand what a stack is and what a queue is. And I hope this video is finished under 5 or 6 minutes. Alright, so we know what a stack is. Alright, it's like stacking books on top of each other. Alright, it works on the principle of last in, first out. So the topmost element right now, the top pointer right now points to 30, right? So if I remove 30, if I pop 30 from the stack, now my top pointer would point to 20. Okay. If I remove 20 as well, my top pointer would point to 10. Okay. Now if I push in 3 elements, 2, 3 and 4, now my top pointer would push into 4. Alright, so this is the basic working of stack. Alright, so we declare stack like this. Okay, also noteworthy thing, we cannot use iterators to traverse through the stack. It is built on the containers like vector, but intentionally it hides the containers iterators to enforce the property of last in first out. So st.push, the push function would push the elements into the stack. Okay, in place does the same thing. In place and push, they do the same thing. And why is in place much better than push? You can check out the videos on vectors. I have given the link in the description on why in place is better than push. Alright, so you can check it out there. So st.top, st is the name of our stack, and top, top, so it returns the topmost element. It prints the topmost element, that is the topmost element. Okay, st.pop, it removes the last element. Okay, cout, st.size. Okay, so this is going to give us the size of a stack. An empty function, you know, it is from the vector. We checked it in the vector, we saw it in the list and dq. Okay, so what it does, it checks whether or not the stack is empty. Okay, it returns 1 if it is empty, it returns 0 if it is not empty. So we can, if we cannot traverse through the stack using iterators, then how do we traverse through the stack? So simply we can make a copy of that stack. We can create a temporary stack. Okay, store the original stack into the temporary stack. And while the stack is not empty, we can pop each element. Okay, we can print the topmost element first and then pop the same. So this way, our original stack remains intact and we can traverse through the whole stack if we need to. So if I run this, this is what I get. So the topmost element is 6. Okay, now I pop 6. So what is the size? 1, 2, 3, 4, 5. 5 elements, so 5 is the size. Is it empty? No, it is not empty. False. And here is the traversal of the stack. Alright. Very similarly, we have the same functions for queue. Now again, we cannot use iterators to traverse through the queue. This is because it is built on containers like dq. Okay, not a vector here, but dq. It intentionally hides the iterators to enforce the first in first out property of the queue. Again, we use the push function to push into the queue. We use the pop function to pop the last element. Okay, size function to determine the size. Okay, q.back to determine the last element, and q.front to determine the first element. And again, we can traverse through the queue by copying it to a temporary queue and then emptying it by displaying the front and then popping the same element. Okay, so let us quickly discuss what a queue is. Okay, so queue here, I suppose I have pushed in 5 elements here. So every time I push in an element into the queue, my rear would be updated. If I insert 20, then rear would be here, then here, then here, then at the end the rear would be here. Okay, at the end my rear would be at 50. Now this is my rear, that is, this is the back, this is the back, R or back. Okay, rear or back. So if I go with the query, suppose q is represented by q. So q dot back. Okay, so this is going to return me this element. And if I do q dot front, then it is going to return me this value. Alright, as simple as that. Okay, As simple as that. Okay, so now we're going to discuss about the priority queue. Okay, so I'm also going to cover priority queue because all the functions are mostly the same. There's just a small difference here. So what does the priority queue do? So priority queue is literally the same as the priority queue. The only difference here is that priority. We are giving priority to something, and what are we giving the priority to? The largest data. Okay, the largest integer in this case, since the data type is integer, we are taking the largest integer. If it was characters, then we'll take the biggest character. Okay, if we are taking strings, then it will select the string which is lexicographically the largest. All right. Okay. So we are pushing 5, we are pushing 2, we are pushing 8. So the order is 8, 5, 2. We we first did 5, then we pushed in 2. So 2 will go behind. We then pushed in 8. So 8 will be at the front. Then we pushed in 10. So see, 10 should be at the front. Okay, this is a mistake here. So 10 should be at the front. Now, if I see the top, if I check the top, it is 10. If I pop, then I'll get 852. And top is now 8. Okay, so if I run this, I'm going to get these as the output. Okay, so now I want my data to be in the ascending order. Before we were giving priority to the highest element. Now we'll give the priority to the least element. So for that, we give this as an argument while we are declaring a priority queue. So we take the data type, we declare the vector integer with data type integer, and we take the greater integer. Alright, and now if we push 5, then we push 2, then we push 8, so see, we get 258. And place and push are same as we have discussed already, so it's going to be like this. So this is all what the priority queue does. It gives the priority. If we want it in the form of ascending order, then we'll write this. Okay, and if we want it in the normal default form, then we'll write just this to declare it. As simple as that. And this is also known as the minimum heap, because internally queue uses a tree. Alright, queue uses a tree to sort the elements. So thanks for watching. Hit the sub if you like, and goodbye.